Hey everyone, in this video I'll be walking you through the QUIC protocol and showing how it works using a Wireshark packet capture. We'll start with what QUIC is, why it's special, and how it compares to traditional protocols like TCP. And at the end, we will be going through some actual QUIC traffic and break it down on what we see. So let's go into it. So what is QUIC? Well, QUIC stands for Quick UDP Internet Connections. Well, QUIC basically stands for Quick UDP Internet Connections. It is basically a modern transport layer network protocol that is built by Google. And now it is standardized by the IETF. It runs on top of UDP and is designed to combine the best parts of TCP, TLS, and HTTP 2, all in one fast and secure package. So why was QUIC so quick? Why is QUIC so quick? Because unlike TCP, it doesn't need a slow and boring three-way handshake. It can establish a connection and encrypt everything in just one RTT, which is round trip time. That's uh that's one round trip time between the client and the server. Basically, it's like let's do an example. Basically, QUIC is like going to a party, get into the house, and said, "Hey, I'm here," and starts dancing. No formal greetings needed. You know. Now I'll go through some quick characteristics. Um, it uses UDP instead of TCP. It is built in TLS 1.3 encryption. It doesn't need a separate TLS layer because it works with handshake at the same time. That's why it's so fast. It supports multiplexing, so multiple streams of data don't block each other. It handles connection migration, which means that your video, for example, this video, won't be cutting out if you switch from Wi-Fi to mobile data. You know, typical situation where you go out from your house and um, your you are switching to mobile data, and your YouTube video keeps going. It doesn't get interrupted. You know. And it also has a faster connection setup and reduced latency. Now, let's compare QUIC versus TCP directly. As I have mentioned before, the handshake, TCP needs a three-way handshake plus the TLS setup. On the other hand, QUIC does it in all just one RTT. That means that the three-way handshake is combined with the TLS setup. On the security side, TCP needs TLS added on top of it. QUIC has TLS 1.3 built in from the start, which makes it faster. Now, multiplexing. On the TCP side, we have this multiplexing problem, which we call head of line blocking. When TCP sends multiple data streams, all the data is delivered in order. So that means that if one packet is lost, the receiver has to wait to get it before processing anything that comes after that. Even if the other packets arrive perfectly, they get stuck in line until that one missing piece shows up. But QUIC fixes this with independent streams. That means that we doesn't longer have head of line blocking. As mentioned before, we have this connection migration advantage, which TCP doesn't have, but QUIC can handle it, and it will be handling it with connection IDs. which I'll be showing you later. Now, let's look at QUIC in action using Wireshark. Alrighty, now let's go through the Wireshark analysis. Here we have some QUIC filtered packets, which we can see here. These first three frames are the TLS plus handshake, three-way handshake part. You can see that this is the packet number 1, 1, and 2, which is client, server, and client. You will see it here, yeah. Now, let's look at the first packet. We can see that the first client initial sent over UDP destination port 443, which is QUIC default port. Now, if we go down a little bit, we can see that here we have the TLS 1.3. We can see also the client below. We can also see that it supports multiple cipher suites, which is the encryption mechanism it is using. Now, I will go to, well, before that, this is the destination connection, which I have mentioned that you can actually move from one Wi-Fi connection to, for example, data connection, and your session will still there. That's because it's thanks to this destination connection ID. We will see now in the second packet that this is actually source connection ID here. Now in this second packet, here we can see the acknowledge of the TLS plus handshake of the client side. Here we can see that TLS 1.3, we can see that the server hello, and we can see the model of the encryption. Now it's good to mention that in the acknowledge in TCP is on byte level, in byte sequence, which is normal because it's only a three-way handshake. But on this case, QUIC have a knowledge of entire packets. Now let's go to the third packet. In this third packet, we will see the destination connection ID here. We can see the acknowledge of the server hello, and from here on everything will be encrypted. Also, it's good to mention that, as you can see, this is basically one RTT. QUIC only does three-way handshake plus TLS 1.3 in just one round trip time, which is really fast, which compared to TCP, it takes 2 round trip times. So after this, everything is encrypted, as I mentioned. So we won't be able to see things like HTTP3 GET requests unless we have the keys. Now let's go to the conclusion. To wrap this topic up, we can say that QUIC is fast, secure, and modern. It is designed for today's internet, where the encryption, it's by default, it's efficient, and it's also ideal for things like video streaming and web browsing. You have probably used it already. YouTube, Google search, and even Zoom rely on QUIC. And now you know what's going on behind the scenes. So yeah, that's all. Thanks for watching and stay QUIC.